Okay. So, how's everybody feeling about the material so far? Is anybody on?
I feel good about the material, but not so great about the ADX studying I've been doing.
Yeah. Now, as far as the ADX goes, remember, it's just going to benefit you a lot down the road. But is there anything that you're struggling with? Or
It's just mostly like how many questions there are.
yeah, it's a little overwhelming.
I feel like I can't really like study for this class when I have to spend like hours and hours going over the ADX questions, but I guess that's why I probably should have started studying for that earlier.
No, and it's we understand. Um, you know that does take a big chunk of time out of your day. Is it the amount of class time that we're spending in class, or is it the?
I don't know. It's just the amount of time I have outside class. I feel like isn't as much as I need to study the ADX and do studying for this class too. But I should be able to catch up this weekend, so hopefully it'll be all right.
Okay. So I'm just gonna show you guys this Dauntless software real quick. I know you guys have the Shepherd Air, but I'm just gonna kind of help you guys visualize some of the stuff that we're talking about and in helping you guys study for the test, because it is overwhelming. I mean, you look at it right now, there's a total of what is it? I know it shows me the total number of questions. Oh, select all. Yeah, it's a good number there. Probably upwards of about 1,600 questions. Maybe just a little bit less. But in your studying, what I like to do is I like to take just one, and then I just, like we were talking about yesterday, start with the question. As you can see up in this top left-hand part, let's see if we can. There we go. That didn't come out the way I was thinking it would. It's been a while since I've studied for this test. Let me see. I don't know how to get it back to the other view. Anyways. Yeah, in Shepherd Air, the nice thing about that is it only will show just that answer. But I go through it to the point where I'm just clicking through this stuff like practically that fast, when I'm memorizing it. When I get to questions like this, where it has, you know, several things that are the same throughout all of the questions, I find the one thing that's different. So 6,000 gallons. So I just find the one that's, I find the difference, kind of that key word in the entire questions, and that, or in the entire question, and that's all I look for. Um, you know, 48 hours, and that's how I study for it. Is just get to the point where I'm literally going that fast through the test, where it's like through the 42 questions in this section, um, where I don't even have to look at the question itself. I don't have to look at the other answers. I can just see the correct answer, and with the keyword that I pick out, that's all I'm looking for, you know. Um, but yeah, just find that keyword and get to the point where you're just clicking through it that fast.
Maybe it would be easier to memorize if I just started having it show only the correct answer.
Yeah, and that is the easiest way, with just the correct.
How Shepherd Air recommends that you do that through all of the questions to begin with, and do it several times.
Yeah,
only look at the correct answer.
Yeah, and that's what I recommend that you guys do. Is let's see, is follow that to a T. That how it tells you guys to study in the Shepherd Air. You literally have to follow that exactly in order for it to work the way they've designed it. So yeah, I go through showing the correct answer only, and then this gentle introduction. I think on yours it will show the correct answer, but it will show the other answers with it. But yeah, then I just go through and I'll do this until I'm getting 100% in the section. And then I go to where it's more of like an actual like mixed up answers, and I will go through that until I'm getting 100% on all 42 questions for the section, or however many questions there are in this section. And then once I've done that, I'll just go into the next set of questions. I'll drop that one. I'll go into this next set of questions and do the same thing for that. And then the next set. Once I get to this third one, I'll go through after I've gotten 100% on all three of those sections. I'll get all three of them, and I will create a. I'll take those, and then I'll just do this study, just where it has the answers, all of the answers, in a mixed up order, and it's almost like a practice test, but I can continuously study them. And I'll do that for those three sections till I get 100% in those three sections, and then I move down to the next three sections. Does that make sense?
Yeah, that's the way you got to do it.
But
I got to switch up what I'm doing a little bit.
yeah. And we've known some people to literally take like 100 practice tests where they'll just do the full-on practice test, where the computer will randomly generate 80 questions. You have 2 answers to complete, or 2 hours to answer all the questions in the test, or something close to that. And they'll just keep doing those practice tests, and like that will never get you prepared for the test. I don't care if you're generating those practice tests and getting 90%. You still, because of how it generates them, you still won't see the questions that you need to see to prepare for the test. So, anyways, that's the little spiel on the ADX for tonight. Okay, so yesterday we talked about all the, previous FARs. There is a couple things that I'd like to go back and touch really quick in a couple of the FARs that are good knowledge to have. Let's see. Okay. So this is FAR part 91, and we're just going to touch a couple of these. I don't think Adam did it to this one. Nope. Anyways, so what I want to do kind of hit really quick were some of these highlights. The first thing that I wanted to talk about, and I want you guys to take note of this, is this first one. So unless otherwise authorized by the administrator, meaning air traffic control, no person may operate an aircraft below 10,000 feet MSL at an indicated airspeed of more than 250 knots. So there's one of those speed limits, that we've been talking about for our airspace. To go along with that, this one just talks about at or below 2,500 feet above the surface, so AGL is what we call it, within 4 nautical miles of the primary airport of Class C or D, they can't go faster than 200 knots. So, and then the last one for that section is this underlying Class B airspace. Now, when we talk about underlying Class B airspace, I'm going to pull up the little picture that we had yesterday. And remember how we talked about the upside down wedding cake here. This Class B airspace. So when we talk about underlying Class B airspace, so around the airport we've got this first ring, and then at a certain altitude, a specified altitude on the chart, you have another ring that's wider, and then you have the top ring that's a total of 30 nautical miles outside the airport, from the center of the airport. So when it's talking about underlying Class B airspace, it's saying that if you are flying under one of these shelves, but not in this Class B airspace, you can't go faster than 200 nautical miles an hour. So some of you guys might be asking, what is a knot? What is a nautical mile knot? A nautical mile is basically 1.1 statute miles. So statute miles are what normal civilians, like what we use every day. When we talk miles per hour, we're talking about statute miles. So that's a statute mile. When we talk nautical miles, we just multiply a statute mile by 1.1, and that'll give us a nautical mile. It's like 1.14 or something like that. So it's easiest just to remember 1.1. So you can see there 1.14. That's pretty close to 230 nautical or 230 miles per hour. Nautical miles is what we use in aviation, and nautical miles are what they use in maritime. So we're talking like ships. A lot of the terms that we got for aviation came from shipping and sailing. So since we're using a lot of the same type of navigation that they used to find their way across the ocean, in aviation, we use their terms, their vocabulary, I guess you could say, to talk about and measure distances and stuff in aviation. So does that make sense? So so these speed limits are just the big one that you guys have to know is this under 10,000 feet, no more than 250 knots. That one will be important at some point. So it may be on one of your tests. So let's see, the other one I wanted to touch on. I don't know what's not on here, but 91.3, you don't have to write this down. But that's where we get, if you remember me talking yesterday about, what there was a, okay, 1.15. That was close. But you guys remember me talking yesterday about the how responsible are we for the safety of the aircraft. And I talked about the pilot in command basically having the final say. Well, 91.3, even though it's not on here, you can pull it up on the ECFRs. 91.3 says the responsibility and authority of the pilot in command. The pilot in command of the aircraft is directly responsible for and is the final authority as to the operation of that aircraft. So that's where that definition comes from. So let's see, the next thing that I wanted to kind of touch on. And remember, these documents are going to be in the Google Drive. This one's still under day 2 on the Google Drive, but we may just need to go to the ECFR.
Garrett, where were you reading that pilot in command information?
I'm going to go to the ECFR here. If you guys go to ecfr.gov, And then go to this Title 14, Aeronautics and Space. And then 91, I put the link in the Google Drive yesterday. But if we go to part 91, that's there. This page in here just has kind of some of the important FARs that Adam put onto an easier to read sheet. But as for that one that I read about the responsibility of the pilot in command, the authority, it's right here, 91.3. And that's where I read it from. The other important thing to remember as well is in a in-flight emergency requiring immediate action, the pilot in command may deviate from any rule of this part to the extent required to meet that emergency. So, so that's basically giving the pilot in command the authority to, in an emergency, do whatever he has to do to land safely, and get the aircraft down safely. So, just real quick, the other one that I really wanted to hit and just quickly talk about was this right here. So, in 91.179, we're gonna, this is below 18,000 feet. So when operating above 18,000 feet, so going back to this airspace, 18,000 feet and up to 60,000 feet is that Class A airspace, right? And this is where the majority of the traffic's gonna be hanging out. It says, on a magnetic course of 0 degrees through 179 degrees, we file the flight at odd thousand flight levels. On a magnetic course from 180 to 359, we file at an even flight level. So I'm going to throw in your guys' little folder here. Just something I use to remember that. And this is something that I want you guys to write down. We'll get this all zoomed in for you here. So FAR 91.179 says that at or above 18,000 feet. So we're going to start practicing how we would see it in a dispatch release. So FL, or really what you're going to be seeing from now on. So FL means flight level, and 180, we just take off the last two zeros of any number because we know that it's always going to be, we just go by hundreds of feet. Does that make sense? So drop the last two zeros off, 18,000 feet. So at or above flight level 180. we file at, and then it says from 0 to 179, we file them odd thousands. From 180 to 359, we file them at even thousand. So the way that I remember this, and I'm going to put this all big and bold, knee, odd, let's see, sweven. So if you just say that as one big word, knee, odd, sweven. So from direct north to the east down to 179, we file at odd. From 180, the direct south, going west, we file at even thousand. So is everybody good with that?
I like it.
Okay. So we're going to use this Word document. We're going to call this the FAR helps. I know I'm doing it during class and stuff like that, but some of these things I just want to make sure you guys have because of the importance. Now, when we talk about FARs, you don't have to necessarily memorize where the FAR came from, but you do need to know the content. When we talk about these things, you do need to know the content. And so,
Hey, Garrett.
yeah. You there, Kiri?
While Carrie's waiting to come back on, just this is a little different than private pilot because we filed our flight plan at even and odd plus 500.
Yeah. So anything below 18,000 feet, if we're planning on flying below 18,000 feet, that's where that comes into effect. But anything above, you know, that's where we'll file differently. You back, Kiri? Carrie? Okay. It looks like he fell offline there. We'll just wait for him to come back. Okay. So that takes care of that. And the last one that I kind of want you guys to see is this survival equipment for overwater operations. So right here, this is the important one that you guys need to know. No person may take off an airplane for a flight over water more than 50 nautical miles from the nearest shore unless the airplane is equipped with a life preserver or an approved flotation means for each occupant of the airplane. So basically what that says is SkyWest, we can't fly any more than 50 nautical miles offshore. There has to be land within 50 nautical miles of any of our flight plans, any of the routes that we take. So this isn't one that you necessarily have to memorize, but it's good to know that that's kind of our limit, that 50 nautical miles from offshore. So other than that, that pretty much covers 90, what I needed to make sure we got covered in 91. Now let's go back and let's so actually there's one more here. So this one is like I said, this is found under here, under that part 91, and it's found in your Google Drive for yesterday. I'll add it to today as well. But this is talking about RVR. So let me show you guys what an RVR kind of looks like. It always helps me. I'm a very visual learner. Okay, at airports, they have this little laser system here. You can see that runs the length of a runway. What it's doing is it's actually passing a laser beam between the two pods here and measuring the amount of light that's getting through between the two. And what it's doing is it's just trying to see what the visibility is on the runway. So like when we're coming in, it's measuring, these little things are going to be measuring how much visual range we have on the runway. And there's 3 different zones that it measures. It measures our touchdown zone, then it'll measure the center of the runway, and then the last segment of the runway. So we call it the rollout at the very end. So it'll measure touchdown and rollout, and then just the center part of the runway. And when we are coming into land, that's good information to know, because there's visibility requirements on these different approaches that we use. Let me see, where did it go? So the visibility that's, kind of the lowest visibility that we use on our Jeppesen charts to figure out, if we can land at an airport, is this half mile. Well, RVR is measured in feet. So when we're looking at RVR, we've kind of got to translate it into a statute mile. Now, 1 mile is how many feet?
$5,280.
There you go, 5,280. In aviation, for RVR's sake, it's 5,000 feet. So this is just what we use to translate the feet, convert it to a mile. So you can see here we've got quarter, half, 5/8, 3/4, and 7/8, then 1 mile and 1 1/4. So RVRs, when we see RVRs in our weather reports, our METARs, of what's currently happening at the airport. That's controlling. So what that means is that we no longer care about this visibility, because there's times where it'll be reporting a quarter-mile visibility, but then the RVR report next to it will be 4,000 feet RVR. We can say we don't like that number, we like this number more, and that's the number we use. RVR is always controlling. If RVR is reporting, that means that's the number we have to use. So, and RVR stands for Runway Visual Range. I don't know if I actually said that. So, since we're kind of talking about that, and just to kind of keep everybody intrigued here, let's see. So this is what it looks like doing the lowest authorized that SkyWest can land in. Everybody thinks that, you know, if you can't see, you can't land, but this kind of proves otherwise. So I'm going to paste it in here. Why doesn't everybody just click that link and open it up real quick, watch the video, and we'll jump back on in 1 minute. And because if you guys watch it on your screens, it's really jumpy. It doesn't come through very clear. So everybody watch it on your individual computers, and then we'll jump back on. Is everybody done watching that video?
Yes,
That's pretty crazy, huh?
that's pretty cool.
Yeah. The the pilots on are trained to go down even lower than that. If you go into a Cat 3 landing, if you guys want to YouTube those, a Category 3 landing, they basically don't even need to see the runway. Airplanes equipped with what we call auto land, and we'll take them all the way into the runway. It'll even turn on the reverse thrusters and apply the brakes for them. So, but there's some kind of interesting things that you get to hear up in the cockpit there. You could hear when it said 300, you still couldn't see the ground hardly at all. So it's saying that he's 300 feet above the ground. Then 200, that's when you can see the lights. And then 100, you could see the end of the runway. And it calls out minimums. So basically, the computer system, when it calls out minimums, if the captain can't see the runway at that point, can't see the approach light system and the runway at that point, he has to throttle up the engines and execute what we call a missed approach. So he's not allowed to land. Something that's kind of interesting about that is when you have a bigger jet, like a 747 or something comparable, a 777, when they hit those minimums and go full throttle because they can't see the runway, they'll still actually touch down on the runway before the engines spool up to the point where it's producing enough thrust to get them back off the ground. So even though they touch down on the runway, it's still not legal for them to actually land. So kind of interesting. Anyways, and those Airbuses are kind of mean to their pilots. They call them mean names when they're coming into land. But anyways, let's see. So there's just a couple more notes that Adam put on some of these other FARs. Just, go through it real quick after class. Not a big deal. Just talking about like the actual operating certificate, what it looks like. I'd show you guys my dispatch license, but yeah, it's in my car. And that car's not here right now. But anyways, then it just talks about some of the requirements for airlines. So wet leases and stuff like that. Stuff that we don't really ever deal with, but then it talks about some of the management that are required to operate under 121. So it requires to operate as 121, you have to have a director of safety, operations, chief pilot, director of maintenance, and a chief inspector. Those are kind of the minimum required. So that pretty much wraps up everything prior to this 121. So, does anybody need a quick break, or everybody doing good? Let's see. Now, when we go into 121 here, Adam has gone through this document and basically cut and pasted out of the CFR, like I was showing you guys, really the highlights of 121. Now, that being said, he highlighted the highlights of 121. These boxes that are outlined in red, those are ones that you've really got to pay attention to. Let's see if I can see. Let's see. So as you're going through and studying them, the red boxes are things that you really got to know. These ones that are highlighted in yellow are things that are important, but they're more just for information rather than something that you got to know. So in dispatch, well, in the commercial aviation world, we have what we call domestic operations, and then we have what we call flag operations. So what this is talking about is when we talk about domestic, we're talking about the 48 contiguous states, so the lower 48. That is domestic flights. Anything that operates in the lower 48 is considered a domestic flight. Going to Alaska or Hawaii, we still consider that flag because it's not actually connected to everything else. It's not really attached. So we call those flag operations. Flag operations is international flights. Anywhere we go internationally, Canada, Mexico, Nassau, Bahamas, Europe, Africa, Russia, wherever you want to go. And like I said, even Hawaii and Alaska are technically, according to the ACARS, considered flag operations. They are two different, require different handling than domestic operations. Domestic operations are a lot less strict than the flag operations. Then the other part that we talk about in 121 is what we call supplemental operations. Supplemental operations are basically operated by an airline or regularly scheduled flights. But when we do supplemental operations, we're not carrying passengers. That's when we're doing things like what we call ferry flights. We're moving an aircraft to a different location for whatever purpose. We also do maintenance flights. We do reposition flights where we'll have an aircraft that is in one of our hubs and it needs to go and basically get ready for passengers. Excuse me. At another airport for the next day or whatever. We call those reposition flights. Basically, we're just repositioning an aircraft to another airport to pick up passengers. So those are what we kind of throw under the umbrella of supplemental, and they even have a little bit different rules. But when we talk about these, just I may switch through domestic or flag and stuff like that. It's just good to know what they're defined as. So SkyWest, we are strictly a domestic airline. And when I say that, people that are familiar with SkyWest know that we actually have flights that go down into Mexico, up into Canada, and to Alaska and Nassau, Bahamas. We have what we call exemptions from the FARs in our operation specifications. So our overriding document for the airline actually has Federal Aviation Administration approval to operate the flights that we send down into Mexico, up into Canada, and to the Bahamas and Alaska as a domestic flight. So we only deal with domestic operations at SkyWest. So that's what we plan everything as. Once again, I'm just going to reiterate that as we go through these, when I say this is going to be on a test, please be very careful to take notes and make sure. There's even times where I'm going to say you're going to have to memorize this word for word exactly. Please write it down exactly. Don't try to shorthand it. It needs to be memorized exactly the way that it's written. So that being said, let's roll into these 121 FARs, unless you guys need a quick 10-minute break.
I could use a break.
Okay.
Thanks, Garrett.
Yep. We'll jump back on at the 35 after the hour. So. Alrighty. So let's go through FAR 121. Here we go. So a lot of this I'm going to read, but when it requires explanation or if I have a trick to help you guys learn it, then I'll stop and we'll talk about it a little bit. So each certificate holder conducting domestic or flag operations must show that a two-way communication system or other means of communication approved by the FAA Certificate Holding District Office is available over the entire route. The communications may be direct links or via an approved communication link that will provide reliable or rapid communications under normal operating conditions between each airplane and appropriate dispatch office, and between each airplane and the appropriate air traffic control unit. And except in an emergency for all flag and domestic kinds of operation, the communication systems between each airplane and the dispatch office must be independent of any system operated by the United States. So, in in the dispatch world. Who knows what ACARS is?
I do.
Anybody else?
I definitely do because Flagstaff doesn't have it.
Yeah. So, ACARS, we talked about the FMS, and in our airplane down here, you guys see that? This is a little more fancy of an airplane, but if you look down here, these two screens right here, this is the FMS. Well, part of the FMS, as part of the FMS, we have this ACARS messaging system. And basically what it is a way for us to text our pilots. So this is one of the communication forms that we use when dispatching to keep that communication between us and the pilots. And it is a pain in the butt for the pilots to type on. You get a lot of double letters, triple letters, and there's no punctuation, there's no nothing like that. So everything's shorthanded and acronyms, and like question marks, you QQ, things like that. So ACARS is just one of those forms of communications that we'll have with the pilot. The other form of communication that we have is what we call Delta radio. I'm trying to see if there's a map. Some people call it Delta radio, some people call it Atlanta radio, but it's all the same thing. That's not it, that's Sirius XM. What the? Anyways, Delta radio. It's not it either. It's kind of like it's kind of like the backup to the backup. I don't know where there would be a map of it, but basically what it does is it has its own independent frequency, and the pilot will call Delta radio and say, I need to get a hold of dispatch. And they'll patch. We get a phone call, and it's basically a phone operator in Atlanta at Delta headquarters, and they call up and they say, I've got this flight requesting to talk to you. You say, patch them through, and they will be able to talk to you as if over the phone, but it's like its own dedicated radio frequency. So it's kind of a pain in the butt to use. You got to like press star and pound and stuff like that in order to talk, but it's a lot like if you were in an airplane talking to air traffic control. It's kind of similar to that. So but that's our secondary form of communication with the pilots. So, and then when it talks about air traffic control, they just use they've got 2 radio systems on board the aircraft that they can use to talk to air traffic control. So they have 2 separate radios, and they can switch between frequencies. They can contact people on, tune into any frequency, talk to the person, the air traffic controller on the other side. So that's the redundancy for them to be able to talk to air traffic control. So, and we're not going to really go over the rest of the stuff. This is talking about ETOPS. So this is ETOPS is just extended operations. So those longer flights, but nothing that we really use in the regional world. So the other thing that we're required to have is weather reporting facilities. So this talks about what we have to have for weather. Each certificate holder conducting domestic or flag operations must show that enough weather reporting services are available along each route to ensure weather reports and forecasts necessary for the operation. Except as provided in this paragraph of this section, no certificate holder conducting domestic or flag operations may use any weather report to control a flight unless, for a domestic flight, it was prepared by the National Weather Service or a source approved by the National Weather Service, or for operations conducted outside the 48 contiguous states, it was prepared by a source approved by the administrator. And then it says each certificate holder conducting domestic or flag operations that uses forecasts to control flight movements shall use the forecast prepared from weather reports specified in paragraph B of the section and any form and form any source approved under its system adopted pursuant to paragraph D of this section. So basically it's just telling us we have to have an approved weather source. So the National Weather Service is one of our approved weather sources. The other weather source that we get our weather from is a company called WSI. And WSI can, they have their own meteorologists and everything, and they can actually write us forecasts and TAFs and things like that in order for us to operate our flights. We do have some stations that don't supply TAFs. A lot of them are, up in the north, central United States. Talking places like, I think Iron Mountain does, but I think they're kind of spotty. International Falls, places like that. Oh, Adam's pointing out something that I forgot to talk about here. So when it's talking about this rapid and reliable communication, right here. So rapid and reliable communications. Like Adam said, the FAA wants a response in less than 5 minutes. SkyWest, it's 4 minutes. They want to see us responding within 4 minutes of the initial communication. So that doesn't mean that we have to have an answer for them in 4 minutes. It just means that when we receive a transmission, typically what we'll do is when we read it, we'll gather the information, but while we're gathering the information, we'll just tell the pilots, stand by or something like that in order to let them know that we did receive the communication from them, the transmission, and we're just collecting the data that they're requesting. So anyways, back to this section here. So like I was saying, we use WSI, and they can provide that information to us, or we use the National Weather Service. When we're talking about outside the 48 contiguous states, like Canada, will actually use, they've got their own weather reporting system. We'll use WSI still, but they have what they call, Nav Canada? I want to say, yeah. And their NOTAMs look just a little bit different than ours. So we can do like Toronto. We'll zoom in here. So this is Toronto. They do their runway conditions here. They report runway conditions regardless of what's going on. So in the United States, we will only report runway conditions when there's actually something going on. That means like we'll only report if it's raining and the runway's wet, or it's snowing, and we'll report that it's, so much of it's compacted snow, so much of it's dry snow or wet snow, and things like that. Canada, they will report even when it's dry. This one's saying 100% barren wet, so it's just saying that these different runways here are all wet. It's probably raining in Toronto right now, or snowing. But then their NOTAMs actually say what they mean to say. It's not all abbreviated and encoded in some funky language that nobody understands. It actually tells us exactly what's going on. So it says like ILS runway 24 right approach, localizer DME minima, all categories to read 980 feet, 430 feet, 434 feet above the ground, and then 1.25 statute miles. So they're kind of easier to read than the NOTAMs that we publish here in the United States, but
How often are these NOTAMs updated?
each one, that's a good question. Each one of the NOTAMs are, they have a valid time, basically. So like this one, 0200 to 1000 daily is when this runway is closed. But down here we can see the valid time. And it's written like military style date. This is your month, this is the day, and this is the year, and then this is the time. Really messed up, huh? And that's how everywhere publishes their dates. It's like the universal way of publishing a date. So 2018, April 24th at 200 until 2018, May 2nd at 1000 Z. We can expect that runway to always be closed between those time periods. So, yeah. But this is the system that we use to get to meet the FAR. This is a system we use to get our information for Canada airports. But like I said before, we still use WSI regardless. I'll show you what WSI. I was showing you guys WSI earlier. I mean yesterday, so we'll pull up WSI again here. But WSI, you know, it starts out with this, but then we have all of our radar, satellite images, all of our AV charts talking about, you know, the weather, kind of the meteorology pages, whether it be airmets, sigmets, convective sigmets, you know, things like that. Hazards. This is something that you can use in your flight planning to see, you know, where are we seeing some hazards. This shows us PIREPs, so the pilots will actually report something that's going on. As you can see here, like light to moderate turbulence is orange dots, and it tells us an altitude that it was reported at. So we can use this in our flight planning to kind of, you know, help pilots know where the bad turbulence is and stuff like that. And then text. When we do this, we can see, let's pull up Salt Lake City. These are the weather reports for Salt Lake City. So this is what we call a METAR. Remember, METARs are what's currently happening at the airport right now. METARs have a valid time of 1 hour. So this METAR came out at that 23:54 Zulu. And right now it's 24:54, so we can expect a new METAR any second now. But this, like we said yesterday, this gives us our wind, the visibility, the sky condition, our temperature dew point spread, and then our altimeter. And then it'll give us a couple remarks about, you know, what's going on. This stuff we'll talk about, but yeah, I don't want to dive into it right now. It's it'll just confuse you guys to death. But TAFs. So this is a forecast. This is basically looking over the next 24 hours or so, what they expect to happen in Salt Lake City. So we can see that it's a TAF for Salt Lake City. This is the date and time that the report was generated, and this is a valid time. The 26th at 2400 Zulu until the 27th at 6 Zulu. Wind speed and direction, visibility, and then the sky condition. And that's the same on all of these lines. This just has a different, it's forecasting at different time periods. So basically from 2300 Zulu until this next line, which is the 26th at 3 Zulu, then the 17 Zulu, 4 Zulu. That's what they expect to be happening. So that's what a weather report looks like. And this is the software that we're allowed to use at SkyWest. So any questions about any of that? Okay. The en route navigation facilities. So we basically have to show as an airline that we can be accurate with these different navigation types. So for each route that we plan on, we have suitable navigation aids that are available to navigate the airplane along the route within a degree of accuracy required by air traffic control. Navigation aids required for approval of routes outside of controlled airspace are listed in the certificate holder's operation specifications, except for those required for routes to alternate airports. So when we talk about alternate airports, basically we, just file direct. So if we're not going to be able to land at the airport that we want to, we can fly directly to our alternate airport. It doesn't require that we're using these nav aids to get to that other airport. We can just go directly there. But for everything else that we're planning, it requires that we use these navigational aids. And this is just telling us the times a day that were required. So what's required? This next section just talks about, making sure that we have maintenance facilities for our aircraft. So, and kind of where they need to be. So we need to have them within a reasonable distance of the routes that we fly. So SkyWest has a ton of maintenance bases. I want to say we're 23 or 24 right now across the United States. So we know that basically we can get our airplane anywhere we need to do maintenance if there's an issue. So ETOPS, alternate airport rescue and firefighting service, we're not really going to spend any time in that. But dispatch centers. So this one's pretty important. Each certificate holder conducting domestic or flag operations must show that it has enough dispatch centers adequate for the operations to be conducted that are located at points necessary to ensure proper operational control of each flight. So what that's saying is we just need to be able to have dispatchers and enough space for our dispatchers to allow them to do their job, basically. And they need to be in an operation, like somewhere that they can operate successfully. You will see that basically every 121 operation, and when I say 121 operation, and when we talk about 121 operations, that's regularly scheduled passenger services. So like regularly scheduled flights. So, SkyWest, Delta, American, Alaska, any of those. So all of those 121 operations, the dispatch centers are going to be basically at the headquarters for that airline. So, SkyWest headquarters is in St. George. Delta's in Atlanta, Georgia. United's in Chicago, Illinois. Frontier's in Denver. You got Spirit down in Fort Lauderdale, Florida. You got American and Southwest are in Dallas. Alaska Airlines are based out of Seattle. Virgin Airlines were based out of San Francisco before Alaska bought them, but anyways, each one of those centers are going to each one of those headquarter locations that's where the dispatchers are going to be. That's where they run the operation out of. So there's only a handful of places that have multiple dispatch offices. And the only one that I can really think of is Ameriflight. Ameriflight, they do a lot of like small jumps for like UPS, FedEx, where UPS will bring in this big old cargo aircraft full of packages, but they've got to get a handful of those packages down to Cedar City. Ameriflight is the one that operates the flight to take those packages down to Cedar City, because they're not going to land a big old cargo jet in Cedar City. So that's what Ameriflight does. But they have dispatch centers kind of all throughout the United States. So they're split up into regions, and they have dispatchers in each one of the regions. So I don't know that they even operate as a 121. They might be what we call a 135 carrier, but yeah, they're the only ones I can think of that have separate dispatch centers. If you guys haven't been to SkyWest and seen the Operations Control Center, this is not it. Let's see. That's not it either. Anyways, it just looks like an office building with
That third picture right there, Kemet.
this one.
No,
Oh,
the third one.
up here. Yeah, that's kind of what it looks like, but you can't really
That's
see.
an old picture, but yeah,
Yeah,
that's a way old picture.
yeah. But yeah, we have 4 monitors on each desk, and I don't know. It's not all that spectacular. It just kind of looks like an office, a regular office. The only difference being is that there is a lot of talking and laughing and people yelling across to each other and just busy all the time. Some of the other, let's see, airlines. My favorite to see is this is Southwest. And they call it the knock. It's pretty awesome. They have like a half dozen screens each, and then they have all these monitors just lining the aisles. And they'll turn on like baseball games and football games and stuff like that on all those TVs. And they have other information displayed on them, obviously, like on time, like flight completions and on time and stuff like that. Just data, metrics that they've put on them. But then they'll have like baseball games and stuff like that on them too. But it's a pretty big room. They have a heck of a lot of dispatchers. But kind of a cool office setup. SkyWest, the morning shift, hates having their lights on and the night shift love having their lights on, from what I've seen. And so in the morning you go into that room and it's way dark, and we each have lights that we can turn on over our desks. But it's kind of funny because you get some of the old timers or some people just throughout the office, and you turn on your lights at your desk, and they act like vampires melting in the sun and get all upset because you actually turned on your lights. It's kind of funny. But
Do you have your own desk, or are you sharing it with other people who are working different shifts?
so the desks, you move from desk to desk, so you don't actually have your own personal, cubicle that you sit in. They just have kind of like this. It's just a gigantic room full of desks. And let's see. Let's just go back to this one. It's just a gigantic room full of desks, and one day you may be working at this desk, and the next day you may work at this desk. So you are by yourself. So when you are working a desk, it's not like you have somebody sitting and looking at the same monitors you are. But no, you don't have an individual desk. So and that was something that was a little bit different for me to get used to, because I've had my own little office for 6 years. So it's kind of hard to get used to it. You have to get really good at, when you first get there, you have to get really good at setting up a computer how you like it very quickly. And they make you practice even. So that we can pull up. This is what deltas look like. Delta's OCC looks like. Well, that is tiny. But they just have a whole bunch of desks, and then they have all these big old projectors displaying information. So anyways, it's kind of fun stuff to look at. But that's all that paragraph is really saying, is that we have to have our own facility, and it has to be equipped with enough dispatchers, adequate for the operations conducted, and it has to be located in a point necessary to ensure that we have operational control of the flight, proper operational control. So that being said, operational control kind of has a special definition that I want you guys to know. So where do we go for definitions and abbreviations? Who remembers? 1.1. So always remember that, the 1.1. If you're ever trying to define something. So operational control, the FAA has a special definition, and this is something you need to memorize word for word. So don't shorthand it, don't try to paraphrase it. This needs to be word for word. Can everybody see it? I'll paste it on here even. Make it big for you guys. So operational control with respect to a flight means the exercise of authority over initiating, conducting, and terminating a flight. Pretty important stuff right there. So whenever we talk about operational control, now you know what it's saying, what it means. But this will be on a test, and this is a very, very common interview question across all airlines. So does everybody have it?
Good.
All right. So other than that, that's kind of all that we really worry about there. This is talking about supplemental operations. Once again, supplemental operations is everything that, you know, a regularly scheduled airline is not doing a regularly scheduled flight. This is kind of our, you know, gray area flights. This is just some of the requirements. So each certificate holder, and when we talk about certificate holder, that's talking about the airline, conducting supplemental operations seeking route and area approval must show that it is able to conduct operations within the United States according to these two paragraphs right here, and that it is able to conduct operations in accordance with the applicable requirements for each area outside the United States for which authorization is requested. So basically you have to have and have to be able to conduct operations over and the use of navigational facilities associated with federal airways, foreign airways, and advisory routes, and that it will conduct all IFR and VFR operations over federal airways, foreign airways, controlled airspace, or advisory routes. So all this is saying is that we have to fly on published routes. We can't just like, you know, go out there and, hey, look at me, Ma, you know. We still have to abide by the federal aviation regulations and still have to go and comply with the airspace that we're flying in. And then this just tells us that that we have to make sure that the route is safe. Talking about route width. Not super important. But it's just saying that our route, we have to be, you know, clear terrain. We don't want to be flying into mountains. We have to comply with the minimum en route altitudes. When we talk about minimum en route altitudes, we're talking about these altitudes on the chart. So this is our high chart. This is what we these are those airways that it's talking about. So we can see right here, can everybody see where it says MEA right here? So in order to fly on this airway, we have to be at or above 28,000 feet. So
That screen just popped up for me. Where were you seeing MEA? Oh,
Let
up
me
above.
zoom in here.
I just checked, or I just found it.
Yep. So this J136, this is called the jet route. It's one of those freeways that I was talking about, and the MEA is published right above the jet route number. In order to fly on this, at or above 28,000 feet. And we'll go into what all this other stuff means, but yeah, so we have to comply with those minimum en route altitudes. We have to use ground and airborne navigation aids. Comply with air traffic density and ATC procedures. So the required data that we have to have for the airports that we intend to land at is all of this information. So so we have what we call, let me see. Oops, no, I didn't want to plan that. I want to look at it. These airport diagrams. So these airport diagrams just give us a good understanding about the airport. We get a visual aid to help us. This is what the airport looks like. You got two runways that intersect about the midpoint of the 1634 runway, and then you have the terminal environment over here. This is where the tower is. This is where the wind cone is. This is where the VOR is over here. Stuff like that. So it just kind of gives us an overview, tells us the length of the runway and the width of the runway. Gives us an idea of the lighting system for the runway. But then here's where we can find the actual textual data for each one of the runways and everything that this airport uses. So it gives us radio frequencies and things of that nature. So yeah, just basically tells us that we've got to have, all of that information available to us. Let's see. The other thing is just going back to weather reporting facilities. And where we get our weather reporting from. Reiterating en route navigational facilities. It's telling us that they're not required for any of these operations. So VFR, we're talking about visual flight rules, meaning that we're referring to, in order to fly the route of flight that we're using, we're not using any instrumentation in the aircraft. We're solely going off of visual references on the ground. And we just do not do that. A lot of times we are way too high above the ground to have real good visual reference points. So we use instrument flight rules, IFR. So communication facilities for supplemental operations. It's not very much difference from what we already talked about. And when you're at an airline, we operate a supplemental flight identical to how we would dispatch a regularly scheduled flight. The only difference is when we generate the actual release that I showed you guys yesterday, rather than saying dispatch release, it'll actually say flight release, and it's only used as reference. The pilot doesn't, we aren't required to technically give him that. The pilot should be responsible for that. But as an airline, we have all the software and we're planning flights anyways. So we just generate those flight releases for them. So, but we operate them basically identical to how we would operate any other flight. So that's why we aren't going to spend a ton of time on supplemental. And this just reiterates the maintenance facilities. So just got to make sure that we're taking care of our aircraft. We don't want, those really bad malfunctions to happen in flight. So flight following system. We have to have an approved following system that established in accordance with subpart U. This is a subpart that we're going to take a look at, but of this part, adequate for the proper monitoring of each flight, considering the operations to be conducted. So kind of like that flight aware, that's like I was telling you guys before, we use a software called Fusion that allows us to filter and do a lot of manipulate the map to show us what the information we need to see. But it looks fairly similar to that flightaware.com that we were playing with yesterday. So we need to, we talked about yesterday the responsibilities of the dispatcher. Here you can see one of those responsibilities. To ensure the proper monitoring of the progress of each flight. With respect due to the departure point of origin and the arrival at its destination, including intermediate stops and diversions therefrom, and maintenance or mechanical delays encountered at those points or stops. So, important to remember that we got to monitor the progress of each flight. And then the other reason why we need that software is to ensure that the pilot is in command is provided with all information necessary for the safety of the flight. So, we had the first one of our sole responsibilities, monitoring the progress of each flight. Here's the second sole responsibility of the dispatcher, to ensure that the pilot in command is provided with all information necessary for the safety of the flight. That's why we flight follow. This the number one most important part of our job. Releases are high up the list, but when we're pumping out all these releases, the important thing to remember is that those flights are on the ground where it's safe. Everything that goes up has to come down at some point. So the most important part of our job is to ensure that the flights in the air are being operated safely. So if there's any information that we can give those pilots to help them operate the flight safely, we need to be giving that information to them. The other reason why we flight follow or one of the other requirements is, we have to have it for our employees, but it's up to the airline to provide that information to outside sources, kind of like FlightAware. And then flight following system needs not provide for a flight following system need not provide for in-flight monitoring by a flight following center So we don't have to have a separate facility just for flight following. We as the dispatchers can do that from the same desk. So so that's the flight following bit of this. This is the actual requirements for that system. Basically, we have to have adequate facilities and personnel to provide the information to the flight crew of each aircraft, the person designated by the certificate holder to perform the function of operational control of the aircraft, and the system must have the means of communication by private or available public facilities to monitor the progress of the flight. Then the certificate holder conducting supplemental operations must show that the personnel specified in the paragraph A of this section and those it designates to perform the function of operational control of the aircraft are able to perform their required duties. So basically, they just have to designate who's doing the flight following, and they have to be able to provide the information to the crew.
Garrett?
Yeah.
No, doing cross-country flights, we could request flight following from the FAA, from the ATC we were heading. Is this the same basic idea then, except it's done by the airline themselves?
Yeah, so if you remember the flight following from when you were actually flying in the private environment, general aviation environment, do you remember the requirement or the little ad lib that they'd put in at the end of that paragraph talking about that?
I don't.
So ATC will only give you flight following if it has the room or the capability to do so. So basically, we can't rely on air traffic control to do our flight following for us because they already have enough on their plate, basically, is what it's saying. So when we operate as an air carrier, we're required to have our own flight following. Does that make sense?
Yep.
So, yeah, that's the big difference is, in the private environment, it's like one or two airplanes may request flight following. And if ATC is not too busy, they'll provide vectors and headings and speeds for us to help us along our route. But in the airline environment, there's just way too much going on for them to provide that same assistance to the airline. So that's why the FARs, they're stating that flight following system has to be ran by the airline. This part talks, it has this bolded part here. Effective length of the runway for landing means the distance from the point at which the obstruction clearance plane associated with the approach end of the runway intersects the center line of the runway to the far end thereof. Holy mackerel, why can't they just put this in easier vocabulary? Because that's not how they work. Just because a runway is published and says we've got 12,000 feet of runway, that's not what we plan for. Is what that's talking about. We have to plan for a certain percentage, and you guys are going to see this question pop up in the ADX. basically we can only plan for 60% of the runway. So on our regular flights. So if it's a dry runway and everything like that, we can only plan on landing on 60% of that. So you'll see that question pop up in the ADX, and you'll just kind of go, "Oh, that's what he was talking about." In this environment, we just don't plan to use the entire runway because we don't want to push our limits, basically. The FAA doesn't want us to push our limits. So that's what we consider the effective length of the runway. For the purposes of obstruction plane clearance plane, this means a plane sloping upwards from the runway at a slope of 1 to 20 to the horizontal and tangent. Holy mackerel, this is just way too much gibberish. So touchdown is at least 1,500 feet from the beginning point. Yeah, I mean, it's a whole bunch of gibberish that you just don't really need to know. And we'll talk about aircraft performance and things like that a little bit later and actually dissect some of this when we're talking about, planning for runways. But I don't really want to get into that. That's just a whole bunch of nonsense right now. So as you can tell in this section, we're not we're a turbine engine powered airplane, and we have to comply with this section. Unless we operate with a turbo-powered airplane, which turboprop airplane, which we don't anymore. So basically, this section doesn't really necessarily apply to us. So turbine-powered aircraft takeoff limitations. So before we continue on here, why don't we take a dinner break? Let you guys go get some dinner. You guys okay with 20 minutes again?
That's fine.
All right. So let's plan on getting back on at 7:55. Actually, let's just make it an even 8 o'clock. How about that?
Sounds good.
All right. All right. Is everybody back?
Yep.
Okay. So, all right. 121, 189. You got all of this stuff here. What's really important to remember from section 189 here, 121, paragraph 189, I don't know how you want to say it. The important stuff that we need to remember is that the takeoff limitations, no person operating a turbine-powered airplane may take off that airplane at a weight greater than listed in the AFM for the elevation of the airport and the ambient temperature existing at takeoff. So, this little paragraph here. That's really what's important. All that's saying is the AFM is our airplane flight manual, and we have performance limitations for each of our aircraft. So all it's saying is that we have to operate within the performance guidelines of the airplane flight manual. As far as the elevation and ambient temperature. Now, where we see that applied the most is places like Phoenix and Denver and Palm Springs, places like that, where it gets really hot, and they're at higher elevations, so or a combination thereof. So that's really where we see those. It's like dead of summer down in Phoenix. We may not be able to take off just due to the outside air temperature because it gets crazy hot down there.
Could you elaborate on why?
Yeah. So our engines produce, well, let's see. How do I put this? So I kind of talked about what we call density altitude yesterday. And what density altitude is pressure altitude corrected for, altitude corrected for non-standard pressure. Is that the correct definition? I'm trying to remember back to my private pilot days. But what it's saying is that when it gets really hot, the engine may perform okay. So let's take a quick look here. So I'm going to open up this nifty.
When I was in Flagstaff, we got weight restricted in the summer and the winter because of this, and it was something that drove our station into science lessons, trying to figure out what specifically about 7,000 feet and 80 degrees meant we had to take half of the flight off.
Mm-hmm.
But in Flagstaff, that 80 degrees is pretty high for 7,000 feet elevation.
Yeah.
So we all became little scientists trying to figure out why.
Yeah. So, and once again, we're going to go over this a lot more in depth when we get into meteorology, weather, and stuff like that. But, okay, take a jar of air. And we got thousands of feet here. Think of the oxygen, the air molecules. Think of them as like feathers or balls. Well, I like to think of them as like a feather because a feather's ultra lightweight, you know. But when you think about, like, if you were to take a column and just start a tube and start putting feathers down that tube, where's the most dense or the most amount of feathers going to be found? At the very bottom of the jar, right? Well, air molecules in the atmosphere are kind of the same exact thing. Acts kind of the same exact way. So the most air molecules are going to be found closer to the ground. So we call this sea level, right? Oh, hold on. Okay, this is what I'm looking at. This is what I'm trying to show you guys. So think of these air molecules just being stacked up really heavy down at sea level pressure, right? So this is where we talk about density altitude. The higher in elevation you go, think of those feathers, and the higher up the tube you go, the less actual amount of feathers will be there because the weight of the other feathers and things like that. They're more compact down at the bottom of the tube, and then they're not as weighted down at the top, and so they're kind of floating up near the top. And there's a lot fewer air molecules higher up in the atmosphere or feathers in the top of the tube. So when we're down here at sea level and we have like a normal temperature day, we have what we call standard temperature. At that point, the engines are able to pretty much take in as much air molecules as they can. And remember, when an engine is generating thrust, or think about it like a car engine, you have your air filter on there. When it's sucking in that air, it's using that air to mix with the gas and combust, and it forms like a little mini explosion inside the engine. It's the same thing with the jet engine. They are cramming down as much air down the inlet as they can, and it's taking that air, mixing it with fuel, and combusting it, so exploding it, and that's what's generating the thrust out the back of the engine. So as you get higher in elevation, the less amount of air molecules the engine's able to grab and use for that combustion. And so it's not able to produce as much thrust. So when we have really hot temperatures, that kind of makes the airplane feel like it's at a higher altitude. So if you have a high elevation airport, think of like Flagstaff, 7,000 feet. At 7,000 feet, there's very few air molecules in the first place. Then you get a really hot temperature as well, and it reduces that even more. So the engine, you may be at 7,000 feet, but the engine is going to perform like it's at 10,000 feet. Because it just doesn't have enough air to grab. Does that make sense?
Very much, yes.
So, so that's just kind of the way it works. But you have like Phoenix that's down at 2,000 feet, but Phoenix gets up in that 120 degree range. And when it's up that high, the engine performs like it's at 10,000, 12,000 feet, just like it would in Flagstaff at 80 degrees. So that's why we see weight restrictions, but there's a limit as well. And in that airplane flight manual, they actually put a limit. When the airplane thinks that it's taking off a runway at this altitude, it'll just give us a temperature. It'll give us a temperature for a specified airport. If it thinks that it's taking off at that altitude, basically, we're not able to do the flight because the airplane just won't have enough thrust to get off the ground. So, has anybody seen American Made with Tom Cruise?
I haven't.
Yeah.
Anyways, there's a part where he where he actually loads up his plane with a whole bunch of I don't want to give away the plot of the movie, but anyways, he loads up his plane, and it's really hot outside, and they're trying to put extra people on his plane and stuff, and he's just like, no way, I either take the cargo or the people, and that's it. And so he ends up with the cargo, but still with how hot it is and everything, he's like overweight and everything, trying to take off a dirt runway, and he like barely gets off to the point where he's like literally cutting the tops of the trees off as he flies over. He's in the middle of a jungle, and he's just like slicing through trees because of and that's a lot due to that density altitude and the engine just not having enough power to get off the ground. But anyways, yeah, that's kind of the skinny on density, altitude, and engine performance. Like I said before, we'll get into that a lot more. Talk about what pressure altitude is and what density altitude is and things like that. And remember that everything that we do as far as that's concerned is safety related. We have to operate safely. Think about like how many people would want to fly if we weren't operating safely and we had just constant, aircraft accidents. It'd be a really bad deal. The Southwest thing. Luckily, we don't see incidents like that happen very often in the aviation world. But when they do happen, think about the damage that it does to the entire airline industry. People that were kind of nervous about getting on an airplane in the first place really are scared to death and just won't do it if they have the option, when they're, especially around the times that there's an accident in the airline industry. So we try to keep those down to the absolute lowest possible amount that we can. And the other thing to remember about these FARs is the FARs are all written because of, well, I'd probably say 99% of them are written because of an accident, an aircraft accident that has happened, that kind of forced the FAA's hand into writing a regulation. So, back in the day, they probably had aircraft that didn't really pay attention to their AFM, and they were just, finding any excuse to get an airplane off the ground, and it caused an accident, which made the FAA go in and say, hey, you can't do this, and that's why we see this regulation in there. And the sad thing is a lot of those accidents cost people their lives. So that's when we tend to see the most action taken and regulations put in place. So, and if Adam, he currently doesn't have a mic, but he has some stories about some of the accidents that have happened in very recent years that have spurred new regulations to be written. But I'm sure he'll share those with you guys at some future point in time. But anyways, that's what I need you guys to take away from from 189 here, is that we got to operate in the limitations of our AFM. So all this other stuff is just kind of like, no kidding, like the takeoff run must not be greater than the length of the runway. Like, how genius is that? But once again, it was written because somebody obviously thought that they could take off and use more than the runway data that they were given. So but yeah, basically we got to perform and stay within our AFM regulations. All right. So here we go with some of our emergency stuff. When we talk about these airlines operating, a lot of the aircraft that we use have multiple engines. So we have a section about one engine inoperative. So that being said, we have to prepare, and a lot of the safety requirements that we have in this 121 world are based off of one engine performance. We always plan for an engine to go to fill at some point, and that way when it does fill, we've already planned and we're ready for it, you know. So no person operating a turbine engine powered airplane may take off that airplane at a weight allowing for normal consumption of fuel and oil that is greater than that which, under the approved one engine inoperative en route net flight path data, blah blah blah, will allow compliance with paragraph of this section based on the ambient temperatures expected en route. So this just kind of reiterates what we saw in 189, but now it's talking about one engine in op. So this part right here, this is what we call method 1 and method 2 drift down. So this is talking about drift down alternates. This is method 1 and method 2 is what we refer to them as. And this is something that I need you guys to take a note on. Take notes on. I know it's not highlighted here, but it's something that we'll talk about during flight planning. So method 1 and method 2 drift down alternates are alternates that we plan just in case one engine fails on us. Method 1 here, basically what we're talking about is if an engine fails as we're rolling down the runway and are about to rotate back, we get to that point where they're like, okay, this takeoff's a go, and they start pulling back on the stick. We call that like during that time, when they start pulling back on that stick, all of a sudden we have an engine failure. This is what it's talking about. So with method 1, we plan that there is a positive slope at an altitude of at least 1,000 feet above the terrain and obstructions within 5 statute miles on each side of its intended track. And in addition, if that airplane was certified after this date, there is a positive slope of at least 1,500 feet above the airport where the airplane is assumed to land after the engine fails. So the important thing to remember about method 1 drift down alternates is that we plan for the engine to fail at what we call a speed we call V1. So engine fail at V1, and that we clear all obstacles by at least 1,000 feet within 5 miles of our intended track. So that's the note I want you guys to write. Engine fail at V1, clear all obstacles by 1,000 feet within 5 statute miles of our intended track on either side of our intended track. So a total path of 10 miles wide, but 5 miles on either side of our intended track.
Could you repeat that one more time?
Yep. Okay, so engine fill is planned at V1, or the engine is planned to fill at V1. We're going to clear all obstacles by at least 1,000 feet within 5 statute miles on each side of the intended track. This is one that you guys can paraphrase a little bit. Don't feel like it has to be word for word, but know that you're failing at V1, clearing all obstacles by 1,000 feet, 5 miles on either side of the intended track. Okay. Okay, method 2. So number 2 here, method 2, drift down alternates. This is when we plan for the engine to fill at cruise. So we've climbed out of the airport and we get up and we're cruising along at 28,000 feet and we have an engine failure. Method 2 is basically when that engine fails, we plan on the airplane not being able to make it to the destination. So with method 1, we plan on them making it all the way to the destination airport and meeting those requirements. Method 2, we don't plan on them being able to make it all the way. We don't plan on them being able to make it all the way to the destination airport and meeting these requirements. So with method 2, the important thing to remember is that the engine fill is at cruise, and we're clearing all terrain and obstructions within 5 statute miles of the intended track again by at least 2,000 feet vertically. So that's the important part to remember there. Failing at cruise and clearing all terrain and obstructions within 5 statute miles of the intended track by at least 2,000 feet. Does everybody have that? All right. So method 1, method 2, drift down alternates. So this just kind of talks about it a little bit. The engine fails at the most critical point en route for part 1. And then the airplane passes over the critical obstruction after engine failure at a point that is no closer to the obstruction than the nearest approved radio navigation fix, unless the administrator authorizes a different procedure based on adequate operational safeguards. It's used for adverse winds. We don't do any fuel jettisoning. But this is basically saying that if they need to, they can dump fuel out the back of the airplane. The alternate airport, so these drift down, we call them drift down alternates. What it's saying right here is that it still has to meet our alternate requirements. So just as if it was a destination alternate that we were planning on, this airport, these drift down alternates also have to meet those same requirements as any other alternate airport.
I have a question.
Yeah.
So if there is a failure in flight, is there like I don't know what to call it, like a special team or a person that steps in to help with that flight to get it where it needs to go, or are you solely responsible to do that?
You're still responsible, but that's a good question. We'll use our dispatch supervisor. We call it DRM. So DRM, we're going to be using the people, the resource management. We're going to be using the people around us to help us. So we'll contact the supervisor if there's an emergency and we've got dispatch releases that still need to get out. We'll contact the supervisor and we'll say, hey, I just had an engine failure. Can you pull a couple flights from my desk so I can get this taken care of? And the supervisor will do all the background work for you. He'll be like, yep, and he'll start pulling flights off your desk so that you can take care of the emergency. Because you as a dispatcher, as we said before, are solely responsible for monitoring the progress and issuing any safety information for the flight, correct? So when we're doing that, this is still our flight. This is still our responsibility. Those other releases we haven't worked, don't really worry about them because those people are safe on the ground. So the soup's going to help us get rid of those extra flights so that we can focus just on that important flight. So as far as a special team, kind of, but not really. You just have the other dispatchers help you out. And the supervisor will also come over and start, if it's something that's serious enough, the supervisor will come over and help you out with what they can. So, so we treat it just as a normal diversion as we would any other diversion. They still have one operative engine, and you can still do a lot with one engine operating. It's just rather than the aircraft being able to stay up at 28,000, 30,000 feet, whatever altitude they're at, they'll no longer be able to stay at those altitudes, and that's why we call it a drift down alternate, is because the plane just wants to start slowly drifting down to an altitude that it can function at and produce enough thrust to keep pushing the plane along. Does that make sense? Or answer the question?
Yeah.
Okay.
It does.
Are you looking for alternative airports or alternate destinations at that point?
Yeah, I mean, so let's pull up a flight release really quick. Let me find somewhere that's kind of got bad weather real quick, just to help me. I don't know. Bad weather is necessarily the I only know one flight number off the top of my head.
So an engine out, is that considered to be in-flight emergency, or is that just?
It can be.
Yeah.
It can be, but it's not necessarily an in-flight emergency. Does that make sense? So, airplanes are meant to fly. It's a glider with a form of propulsion, So the airplanes have a, back from my private pilot days, the airplanes have a drift, or what did we call it?
Glide ratio?
Yeah, glide ratio. And so, with an engine still pushing them along, that glide ratio will extend out quite a bit. So they can still get pretty much with how many airports there are in the United States now, they can still pretty much get anywhere they need to get safely, or land at an airport safely. So it's not necessarily an emergency. It just, they'll get priority handling until the pilot feels like it's actually an emergency, like people's lives are really at stake. Not so much just for an engine failure, but if like all of a sudden they've got low fuel or an engine catches on fire or something like that, then we have an emergency. But an engine failure alone isn't necessarily an emergency. So, but don't get me wrong, air traffic control is going to get them in first. They're going to push people out of the way to help get them in safely. But yeah.
Garrett, I had a question as well. So you've got an aircraft in flight, loses an engine, and from my experience, I know that the crew, the cockpit crew, is talking to air traffic control, and it seems to me that between air traffic control and the two pilots, they would look at surrounding airports as options, obviously considering weather very quickly and all of the factors.
Mm-hmm.
It seems to me that decisions were made between air traffic control and the pilots. But when and how are you as a dispatcher being notified? Because you got that 4-minute response. If you're going to go through the Delta radio or some of the other alternate methods, we don't just pick up dial in a frequency and talk to you as a dispatcher. Mm-hmm. And that would actually create a workload for them. So how and when do you get notified, and what's your immediate involvement? If you could.
So that's a great question. So it all starts with our flight planning. You can see down here, we actually have a section for drift down. So let's say there's an engine failure in flight. We've determined that we can only use method 2. So method 1 is kind of our optimum, like best case scenario. Method 2, we can see that we have 2 alternate airports. So what this tells us, this is a flight from Salt Lake City to St. George. So what this is telling us is if the engine fails between Salt Lake, 30 miles southwest of Salt Lake City, then our drift down alternate would be Salt Lake City. So that's where we'd want the pilot to go. If it fails after 30 miles southwest of Salt Lake City to St. George, then we want them to go to St. George. They can make it all the way to St. George. And so pre-flight planning, we've already told the pilots where we want them to go if they can. And we actually have to look up and make sure that the weather is suitable for them to use these airports. We've looked at the approach charts and made sure that they could safely land at those airports. As far as when there's an actual in-flight emergency, so let's say that the flight is, let's pull up this FlightAware again. So let's just click on a random flight and try to find one that's, so Southwest Airlines. Okay, this is a good one. Okay, let's say that he's flying from Denver to Philadelphia. Okay, let's say that he has an engine fire somewhere just as he's getting into Missouri. You think we're going to want him to turn all the way back down to Denver? Probably not. So what happens is, as soon as the fire, let's say he has an engine fire, what happens on our software, our flight following software, is the captain, if he can, so he's first of all going to try to do what he can up in the air to extinguish the fire or whatever it is. He's going to take, there's a saying, they say aviate, what is it, aviate the navigate or something like that. Oh, aviate, then communicate. That's what it is. So they're going to first make sure that the aircraft is able to, is in a safe, I don't know, environment prior to contacting us. A fire's not going to spark up and they're going to start typing on the ACARS. They're going to try to take care of the fire first. And when they do that, they're talking to air traffic. The first officer is probably going to talk to air traffic control, let them know of the situation. What happens at that point is, if, let's say, they are able to get the fire out, they're going to try to ACARS us, because we're the ones that are actually going to tell them where we want them to land. They're at 37,000 feet. We're going to try to help them with the weather and everything and try to help them pick a safe destination for them to land at. So we know that, we got a couple airports in this area. So we immediately start telling them, this is the weather for this airport. This is what we prefer. This is, if you're able to do these things, this is what we prefer you do, where you'd go. The pilot will, on that FMS, he'll basically put in a diversion code, and he'll show up on our map as a diversion. So he'll highlight, we'll get a big old notification that pops up that says the pilot's diverting. They don't have to communicate with us at all prior to this, but as soon as he pushes that diversion button, he'll pop up big and highlighted on our map saying, hey, something's going on with this airplane. He can't land safely at the destination, or there's an in-flight emergency or something. He'll hit that diversion button, and he will point the nose of the aircraft at what airport he wants to land at. So say there's not been any communication yet, and he hits that diversion button, I'll immediately ACARS him and say, hey, what's going on? What can I do to help you? And hopefully he'll respond. If not, he's taking care of a situation, and we're going to let him deal with that. Air traffic control's going to, be talking to him, because it's a lot easier to hit a mic button than it is to send a text message. He's going to be talking to ATC, and ATC is going to be clearing out a spot for him to file in. But if he can talk to us, he's going to be like, hey, I'm diverting due to an in-flight emergency, engine fire, whatever it may be. And we're going to say, okay, here's the airports that we want you to go to. This is what's current. This is the current weather. This is the distances to those airports. This is how much fuel we plan on you burning to get to that airport. And all of that, we'll just start feeding him with information. And then the pilot is going to make a choice on where he wants to put the plane down. Air traffic control, it's the same situation. In an emergency, the pilot's going to, declare an emergency. Air traffic control is going to say, what do you want to do? And they're going to let him make the call of what he wants to do. And then once he's made the call of what he wants to do, they're going to say, okay, turn to this heading and start your approach. Whatever they have to do to get him down on the ground safely. So really it's situation dependent. If the pilot can, he's always going to notify the dispatcher, and the pilot and the dispatcher are going to make the decision on where to put the airplane down. If he can't, he's just going to be talking to air traffic control to get the plane down on the ground safely. But let's say even like a radio failure happens, doesn't matter. Air traffic control is basically going to clear the way and just, he's not responding. They'll worry about the paperwork and the, what they've got to worry about later. They just make sure that everything's out of his way as he's going down. So I don't know. Does that kind of answer the question? The big thing to remember is that, like, as soon as the pilot makes a decision on what he's going to do, is he's going to push a button on that FMS that says, "Hey, I'm diverting." As soon as he pushes that button, he pops up and he's flashing on our screen. That's when we can start asking questions. But he doesn't necessarily have to respond. I don't know. I hope that answered your question.
Yeah, thank you. I guess if I had thought about it a little more clearly, I guess what kind of established procedure, if any, is there, and so when do we expect to hear from it? Like I said, I just know that adding in that dispatcher communication between the cockpit crew when their hands are full with any kind of a matter involving a quick diversion, I know that creates workload for them that probably is too heavy. But I didn't know if SkyWest had a procedure like, hey, when everything's good, check in with your dispatcher. And where are our responsibilities to assist at that point? Is it really just when they get on the ground and now we're in Memphis? It wasn't our planned destination. Get us to the next, I know that dispatchers have to look at crew, how many hours they have left in their day. Can they even get back in the plane, fuel it up, get it to that original planned destination if they run out of time? And then you got to look at all the other logistics. And so I guess that was a big question. So I think you covered it. Thank you.
Yeah. And one other resource that the pilot's using is, as soon as there's an emergency, he has a manual sitting right between him and the first officer. It's called the QRH, the Quick Reaction Handbook. It's got tabs and it's all filed and nice and everything. They'll pop that book open. The first officer will pop that book open and he'll flip to the charts or to the section that talks about, this is a engine fire. And they'll go through the checklist for the engine fire. They'll try to take care of that first, but in each one of the procedures, it'll either tell them, hey, you need to land at the nearest suitable airport or something like that. And if they have time, which, descending from 37,000 feet down to sea level, they can get it down pretty quick. But, if they were just doing an average descent, that's 15, 20 minutes. There's not that much that they can do to where it's going to consume that entire time. There's a good chance that and with there being two people in the cockpit, there's a really good chance that one of them's going to have the availability to talk to dispatch and notify them of the emergency. Some of the diversions that you see, though, I don't know. I kind of feel like they're planned diversions. You can tell when a pilot's going to divert to an airport. In-flight emergencies, a little different. You never know when those are going to happen. But there's times we kind of have a fuel. Pilots kind of have their own bar as to how low they'll let the fuel get before they divert. Pilots don't like to see low numbers of fuel when they're flying an airplane. When they start running down into the lower numbers, they really get antsy. And so you'll have some holding going on. They'll be in a holding pattern, and all of a sudden we have what we call the ACARS log. So we can actually see what the pilot's doing. The ACARS doesn't just allow them to talk to us. It's also sending them messages as far as takeoff and landing performance. It's sending them information about, it'll send them weather. It'll send them just a whole bunch of different things. But you'll see them in a holding pattern. You'll be watching the ACARS log. and you'll see them run landing data for, let's say they're trying to land at LAX, you'll see them run landing data for Santa Barbara or Ontario, and you'll be like, oh, great, he's about to push the diversion button. And all of a sudden, he'll pop up as a diversion. And you're like, what's going on, Captain? Oh, I was just running low on fuel and had to put this down. LA was telling me that I had a planned time of 45 minutes from now. I've only got 45 minutes of fuel. I'm not going to risk it. It's like, okay, you just know when they're going to divert, so you can kind of like mentally prepare yourself for it. And there's times where you'll see them like do a missed approach or something, or they'll start holding above an airport, and you'll be like, oh, great, this guy's going to divert. And so you'll just be preemptive, and you'll be like, there hasn't been any diversions from that airport today. This is the current weather. I'm showing it's good. Don't divert, please. You don't say don't divert, but you're just kind of like praying that the pilot cowboys up and is like, I can shoot this approach, But once again, you're not in the cockpit. You can't see what's actually going on. And it's the pilot's call on whether or not he feels it's safe. So
in that kind of a situation, Garrett, is that usually because not enough fuel was loaded pre-flight?
No. A lot of times it's just the times that I've seen it, very few times have I seen a captain like hold as long as they can and then decide that they need to divert. Most of the time, the pilots, they just see a number or they hear air traffic control give them an estimated time. So air traffic control will give them a time saying, we're expect wheels down on, like, expect to be touching down on the runway in 30 minutes. That doesn't mean that they're planning on holding them for 30 minutes. It's just like, this is the worst case scenario. And so the pilots take that as the gospel truth, when a lot of times as a dispatcher, we can see how much holding has been over a certain airport and for how long that holding was. So when the pilots get this time and you can see the ACARS log pop up, they just like immediately freak out and they start running landing data for another airport. They're not talking to you at that point, So that's when you just like, hey, Captain, there's been an average holding of 5 minutes into LA. There's only been 3 flights that have held in the last 2 hours, and it's been for 5 minutes. It's not going to be 30 minutes like they said. Just plan on 5 minutes. Just give me 5 minutes. They'll have 20 minutes of holding fuel on board the aircraft, but they're thinking, oh, there's 20 minutes of hold fuel, and they just told me it's going to be 30 minutes before they can get me in, and so they immediately freak out, and you're just like, oh, come on, just give me 5 minutes. I promise I'll clear you in. And like I said, it's just the pilot's call at that point. So when I see an airport that's been holding a lot, A, I'm going to plan more fuel on the flight, but B, I'm going to also, like, when the pilots, when they're getting close to that area, I'll send the current weather. I'll tell the pilot, hey, LA's had X number of flights hold for an average of this time, and there's been no diversions or whatever it is, and try to keep them calm before they get into that situation, before they even get hit with that information from air traffic control. But no, a lot of times we plan them with more than enough fuel, but each pilot has its own. They each have their own like comfort level. We've got a pilot that every single flight he adds on an extra 1,500 pounds of fuel. An extra 1,500 pounds of fuel at cruise, that equates to like, that's like 30 minutes, you know? That's a lot of extra fuel when we've already planned them for X amount of fuel, and we can see things that they're not seeing, you know? They're just going off of like, oh, last week I tried to fly into that airport and got held for 10 minutes. I'm going to add an extra 30 minutes of fuel because I don't want to even call it close. But I don't know. They each have their comfort level, and they each bug out at a different point. You get those cowboys that will take it all the way down into their reserve fuel and then decide to divert. And then you got those guys that the second they hear a time, they're already pushing the diversion button and not talking to you, you know? So each situation is very unique and different, and each pilot is different. So we try to avoid diversions, though. It's inconvenient for the passengers. We try to, if there's going to be a delay or any reason to delay or cancel a flight, we want to catch that before the plane gets in the air. Diversions, it's a huge inconvenience for the passenger. B, it's very, very expensive. The average diversion, the second they decide to divert, we just kind of plan on it costing $25,000 for each one of those diversions. So that's why that pre-planning is super important. But as soon as there's a diversion, though, we try to get them back in the air. We fuel them up as quickly as we can, try to get them back up in the air as quickly as we can to get them to their destination. So we call that a diversion recovery. But anyways, that's that's method 1 and 2 of drift down alternates. It's a little more than, but it's really good to actually talk about that, all that extra stuff, because, you know, I think that's more effective to talk about that stuff than it is to read a dictionary sometimes. So this is talking about 2 engines in operative. We don't need to worry about this because all SkyWest aircraft only have 2 engines. So if you have 2 engines in operative in a SkyWest airplane, you're coming down regardless. So none of this really applies.
Is it asked on the test?
What was that?
Is it asked on the test, though?
Oh, no. Nope. Everything that we test you guys on is going to be practical or something that you would see in like we said, we kind of model it off of the op specs and day-to-day operations of an airline. That's one of the requirements for the school. So we use SkyWest, and we can only ask you questions on things applicable to that.
So it's not going to refer to more than 2 engines on the ADX.
I'm not 100% sure. I don't remember it referring to more than 2 engines. I don't even remember it talking about method 1 or 2 drift down. But the actual dispatch class isn't really directed to the ADX. The ADX is self-study, really. The actual dispatch courses are all relating or directly tied to the practical test. So I don't think there's a dispatch school that actually trains to prepare you for the ADX. I think that's always kind of been a self-study using one of those programs. So, and like I said, the ADX, 99% of that is completely like not related to the actual dispatch job. It's just mind-boggling to me that they ask some of the questions that they do in there, because you will never, ever, ever see it in the actual dispatch world. So, yeah. Landing limitations. So this is talking about, I mean, the long and the short of it is no person operating a turbine engine powered airplane may take off that airplane at such a weight that the weight of the airplane on the arrival would exceed the landing weight set forth by the Airplane Flight Manual, or AFM, for the elevation of the destination airport and the ambient temperature anticipated at the time of landing. So what that's saying is we can't, and let's go back to this flight release here. We have a couple weights on here. So this is our takeoff and landing report. We call it a TLR. What it's saying is, here's our max runway takeoff weight. So if in a perfect world, we could technically load the airplane up and take off with that much weight. But because of this FAR, we can only plan to take off at this weight. Now, this weight here, the way we get this weight is we take the max landing weight of the aircraft. So this is a CRJ 200, and the max landing weight of a CRJ 200 is 47,000 pounds. So what we'll do is we'll take 47,000 pounds and we'll add on the en route burn, which is this number right here of 2039, to give us that 49,039 pounds. So what this FAR is saying is that we can't take off, so 49,039 pounds. We can't take off and plan to land above our max landing weight. And that's, once again, for safety reasons. Just because an airplane has 50, a CRJ has 50 seats and can hold, 15,000 pounds of fuel or whatever it is, doesn't mean that that's what we will load airplane up to. Sorry. So that's what that FAR is talking about. I mean, it's pretty obvious reasons, but yeah, the airplane can only land at a specific weight. So, kind of a funny story about that is I have a friend that lives up in Barrow, Alaska, and does everybody know where Barrow, Alaska is? So it's the northernmost city in the United States. Barrow sits right here. They've got this little runway. Let's see if I can pull up there. Maybe it's no. ABR. Some go off the ICAO codes and some go off the. I know the. No, hold on. Sorry. Gotta use the. Anyways, so Barrow, a lot of times they'll have like contaminated runways, or if we have this ILS, or anyways, there you go, compacted snow. They are in the Arctic Circle, so they've got this little tiny airport. They can technically land 737s on a good day. Let's see, I'm trying to find something here. I don't think I have it open still. And let's pull up the airport data for it. So this is their runway, 7,100 feet long. Think about like Salt Lake International Airport has 12,000 foot runways. So this is like a mile and a quarter, mile and 3/8 long of a runway. And remember that we can only plan for a portion of that runway. So 60%, we can only plan to use 60% of that runway. So that being said, that number drops down significantly. And then we have other factors like my buddy on this flight, the night before they had canceled the flight into Barrow because it was snowing heavily. And so this was the next morning. And that flight going up to Barrow, basically there was, let's say 100 open seats or 100 seats available, and they had booked like 105 passengers or whatever. But with this other flight canceling the night before, they put them way overbooked. But they were only able to, because of snow being on the runway and things like that, which increases the landing distance that the airplane needs. So with all of that kind of piled on top of each other, they could only take out like half the people up to Barrow. So the plane, even though they had canceled the flight before, overbooked this flight and had the cancellation from the night before that was trying to get up to Barrow, they could only fill up half the airplane. And my friend got on Facebook and just blasted Alaska. I can't believe you guys would do this to the passengers getting up to Barrow. This is ridiculous. And just went on this huge rant. And I got on there and I was like, Jake, it was for your own safety. I was trying to talk him down off the ledge. He was so mad. And I was just like, it was for your own safety. What you don't realize, it's just because there's all of those seats on the plane. That doesn't mean that you can stop a freight train on a little, 4,000 foot patch of ice. It's not going to stop. And so when they take half of the passengers off the plane, it's for your safety. It's not because they hate their passengers or they're trying to screw anybody over, So just kind of a funny story about, just because the airplane has all this room and is capable of taking all this fuel doesn't mean that the performance and the way it's set up is going to allow for all of that. So, we gotta look at all these other external forces that come into play when it comes to our flights. And as Elizabeth said, weight restricted. That's a phrase that you guys will hear a lot in your life as a dispatcher. So it's basically just saying we can't put all the people on the airplane, so you guys need to figure out what you're going to do. So the other important paragraph here, basically the long and short of this paragraph, is that no person may take off that airplane unless its weight on arrival, allowing for normal consumption of fuel and oil in flight, would allow a full stop at the intended destination airport within 60% of the effective length of the runway. So that's where we're coming up with that 60%. So that doesn't mean that the pilot can only use 60% of the runway. That just means that's all we can plan for. So we can only plan to use, 4,000 feet of that, or 3,500 or 4,000 feet of that Barrow Airport's runway. But the pilot can use all 7,100 feet if he would like. So planning wise, though, we can only plan to that 60%. And this is something that you will see on the ADX. It'll give you a runway length of 7,100 feet, and then it'll have like a little line through the runway there, and it'll say like 1,500 feet. So you'd have to take like, let's see if I've got my calculator still. So when you're doing these questions on the ADX, you'd take 7,100 feet, you'd subtract that touchdown zone of 1,500 feet or whatever it's telling you on that chart. That gives you 5,600 feet, and then you multiply that by the 0.6 for 60%. That's how much runway we can plan to use for that area, or for that airport. Does that make sense? Does everybody see how I did that?
So that 1,500 that you took away was the 0.50 feet above the intersecting point of the obstruction clearance plane? Okay.
Yeah. So, yeah, like you were saying, the, that touchdown zone. So let's see if I can draw it out here. You guys are going to get used to seeing me draw things with my mouse here, and they don't look the best. It looks like my 4-year-old with a crayon, but it's what I got. So let's see here. Okay, so the way you'll see it on the ADX is you'll see this run. You'll see like a piece of pavement, and then you'll see like I think they have a line here, and it says like an overall length of 7,100 feet. But then this zone here, it'll say, let's just say 1,200 feet for this example. So you've got 7,100 feet total length, and then it'll say 1,200 feet here. So, figuring that out on the ADX, and take that 7,100 feet, we'd subtract the 1,200 feet, and then we would multiply that by 0.6. That gives us the usable runway that we can plan for in landing.
Okay.
So you're going to get like, in studying for the test, you'll have like 30 of these questions, but I think I saw one question on the ADX that actually had that, where I had to
But
figure that out.
in those examples, though, it'll be marked what that obstruction point, how many feet that.
In the question, it'll always have that obstruction distance.
Okay.
We call that the touchdown zone.
Okay.
So
it won't just have a random line and we get to figure out what.
Right.
Okay, I'm just making sure.
So, so that's kind of one of those questions, and that's what this 121.195 section is talking about. Is we can't land over our max, like we can't plan to land over our max landing weight, and we have to calculate, like we can only plan for 60% of the runway for our landing. So you can see really quick though why, let's go back to this takeoff and landing report. So for our CRJ 700, CRJ 200, this is the TLR. This is what we plan, what the computer spits out, basically. So we're planning to land on runway 16 left in Salt Lake City. Takeoff. Let's get to the right section here. Okay. We're planning, this is St. George Airport. We're planning to use runway 19. This is the temperature and dew point and everything. And this is what we plan on landing at. This is the length of the runway here. And this is what the airplane's saying we need in order for the airplane to land. So at 45,430 pounds that we plan to land at, we need 4,011 feet on a dry runway to land. So you can see why that Barrow Airport, why it gets weight restricted, why they have the issues that they have there, why they can't take too many passengers there, is because even a little tiny CRJ 200 needs a lot of runway to land. So, anyways, that's just kind of a fun example. Why don't we? I think that's a good. Actually, we'll do one more paragraph here of the FARs, and then we'll call it a night. After this, we'll be in subpart M. So, congratulations, you're halfway through 121. So, all right. Okay, so 121, paragraph 197 here. Right here. So what this is talking about is our alternate airport. What is the requirement, the landing limitations that we require at our alternate airport? So what you're going to see throughout the FARs is you're going to see, a destination and then an alternate requirement. So whenever we're planning an alternate requirement, they're going to be more restrictive than our regular destination requirements, because when we land, decide that we're going to need an alternate airport, we want to make sure that that alternate airport is more safe than our destination airport. We've got to get the airplane down. Does that make sense? So.
Will you say it again, please, Garrett?
Yeah, sorry. So when we plan an alternate airport, we want to be more restrictive on the requirements for our alternate airports, because than we are on our destination airports. Because if we have to use our alternate airport, like at that point we have to get the airport or the airplane down on the ground. Does that make sense? So we want to penalize it even more for, we want to be even more restrictive because we're going to have to use that airport. Like, our destination isn't good anymore. Our alternate has to be good when we get there. Does that make sense? I'm sorry.
Yeah, okay, that does, yeah.
So you're going to see regular destination requirements, and then you're going to see alternate airport requirements. So what this is saying is that no person may list an alternate airport in a dispatch or flight release for a turbine-powered airplane unless that airplane, at the weight anticipated at the time of arrival, can be brought to a full stop within 70% of the effective length of the runway. So we require there's an even bigger requirement. Does that make sense? I'm trying to. I may have worded that just a little confusing. So with our destination, we plan at 60%. But with our alternate, we're allowed to plan at 70% of runway length. So we're more restrictive on like our weather requirements, but we can be a little less restrictive on our usable runway length or effective length, because an alternate airport needs to be, like I said before.
Well, it says 70% for turboprop and then 60 for turbojet. Am I reading that wrong?
No, it's 70% for. Oh, that's right. I'm sorry, I read it wrong. So yeah. So alternate basically has the same requirement as the destination as far as that goes. 60% more of the effective length of the runway, from the 50 feet above the intersection of the obstruction. So that touchdown zone. So the actual usable length can stay the same, but we're going to be more restrictive on our weather requirements and our landing charts. So Is that confusing enough?
It makes sense that we would want to make our alternate the less desirable option.
Right. Yeah, I mean it's not necessarily less desirable, but it's like we've got to put the airplane down, and so we want to be more restrictive on the weather requirements, making sure that basically giving the pilots more of a padding and allowing them to, if our destination's not good, we really, really, really want to make sure that our alternate's good. And it'll make sense. At some point in the future, it'll make sense, I promise.
Well, no, I remember many a night not being able to leave because we couldn't get into Arcata and had to divert back to San Francisco. So, yeah.
Yeah. So that's just kind of what that's talking about is the runway length. Now, this previous section, it'll talk about this 115%. The reason why we don't really go into this is because in this class we're always just going to plan our runways dry. We're not even going to really go into the actual like landing and takeoff and landing data per se. But all this paragraph is saying is that when the runway's wet or slippery, we need 115% of the runway length. So they're going to like really, really restrict it because it takes a lot longer. As going back to this flight release, you can kind of see that landing data. Where with a dry runway we require 48.13. When it's wet, 54.15. So we penalize this data 115% to give us this. And then when we have snow, it's even more of a penalty.
If I'm hearing you right, the importance is not necessarily the percentage of the runway that you can use, but more that the weight of the plane is what will make it more of a penalty.
It's kind of both. So we have to plan runway length, so the effective length of the runway, because even though we have 9,300 feet of runway, we can only plan to use 60% of the effective length of that runway. So that ends up being in St. George. That ends up being like, let's just say 5,500 feet. Okay. That being said, if our plane is heavier, like this is what we're planned at right now. And if it's dry, wet, or has snow on it, that's how much distance we need to stop. But look at what happens to those numbers as we get heavier at 48,000. Well, we can't land at 48,000 pounds. I mean, so at 47,000 pounds, if we had this aircraft completely maxed out, look at the numbers. Whereas with 430, we needed 4,813 feet of runway. At 47,000 pounds, we need almost 150% or 150 feet more runway to stop. And that's just changing the weight. So it's kind of a combination of the length of the runway, the weight of the aircraft, and the contamination of the runway that come into play as to, whether or not the airplane can actually stop or we can plan to use that runway. So kind of a combination of all of it. So, and this is, we'll talk about thrust reversers and stuff like that. But if we're using the thrust reverser, that'll reduce our landing distance by 800 feet. Things like that. Anyways.
I'm really regretting going one more paragraph.
Yeah. Sorry, I just saw that we were one paragraph away from subpart M, so I was just like, let's just knock it out real quick. But we can dive more into that like next tomorrow. Well, let's talk about tomorrow really quick. I have a funeral to go to tomorrow, and so I will not be available possibly for the first part of the class. We're going to try to get back quick enough, but there's just a chance. In that case, tonight I'm going to post a video for you guys to watch at 5:30. Like if you try to get on to GoToMeeting and at 5:30 and I'm not on there, then just go ahead and kick this movie on and watch this video, and then I'll try to be back as quickly as possible. But I'm trying to think of a way to. I'll send out an email on the time that I plan on being back to teach the class. But tomorrow, just plan on a little bit later of a start time. Like I said, I'll email you guys and let you know for sure what time the class is actually going to start. But I'll give you guys a video to watch for the first part of the class, just in case it's a little longer than I expect it to be. And then on Friday, Adam is going to teach the class. So,
Well, Garrett, on my end, I'd say for sure don't rush. Just handle what you need to handle, and we'll see you when we see you.
All right, sounds good. But yeah, other than that, any questions or anything I can take care of for you guys tonight, or?
Can you explain how the Jazz can blow a 25-point lead in the third quarter?
Because Vegas told them to. When I see things like that happen, I'm like, oh, come on. There's something else going on. There's, and I have a deep suspicion that Vegas has a lot more control on our sports than anyone would like to admit. But, yeah. Well, thanks again